Hello, everyone. Welcome to the system design series. And in the system design series, we are going to design today a proximity service like Yelp. Those who might be wondering what exactly Yelp is, Yelp is a very popular service in United States, which is where the user uses Yelp to find the local businesses and the nearest restaurants. Although the and surprisingly, although Google Map has those feature, Yelp is still surviving and thriving. So if we have to just see how the UI of Yelp is, you can see over here there is a certain distance you can you can put, and based on that distance and based on the current location, like your uh, given location or your current location, it is going to give you the restaurants or some other businesses or uh, the data that you will be looking at. So now when we see this particular system design question, this has a very unique blend in terms of in terms of the front end and the back end design. So if we are just thinking about the back end here, so back end, um, in the back end, of course, like there will be API, there will be API, there will be database, there will be scaling and replication factors, whatnot. And in the front end, a very interesting things comes from the mobile dev perspective, is how the location change, or location updates to be handled. So in mobile application perspective, if anybody is going for any systems round, this is a very unique and a very good question. And often, like, even if there are some variation of this question, suppose anybody asks you to design something like Zomato, or design something like Uber, there are a lot of concepts you can take from here, and you can uh, get into the inference of the those systems. Like from the proximity service, there are a lot of other systems do take inspiration from. So this is a very good question in terms of, or a very good system to design in terms of the back end and the front end, or in the full stack perspective, in the or in any mobile application development perspective. Okay, so now, as we can see, like the primary objective of this is to find the nearby businesses, right? Nearby business, nearby restaurants, um, where did I mess up? Yeah, nearby restaurants, all this thing. So from a user perspective, so if I'm just a very like if I'm an end user over here, okay, so just think that this user, what he is going to do is, he has a mobile application, and um, that particular mobile application is going to get some data. This this mobile application is going to get some data from a certain database, where the uh, all the information about the business will happen. So let's think about what are the parameters that we are going to pass. So of course, the moment this user is going to hit this database or the API, so he is going to pass his location, that is the latitude and the longitude. And after the location, also alongside that, also they might be looking into something like radius, because we need to understand like how far the a certain how distance, how far or in what distance a certain business is. I want to explore, like if I just want to see something around my 2 mile radius, so that will be a different kind of a result set it will return. If I am going to explore something around 10 mile radius, of course the result set will be way more, right? So mm the thing that we are going to do over here is, result set will be different, right? Like for different radius. So what we are going to have is we are going to have endpoints like this, where the the get parameter, or sorry, the get request will be like at first will be the get nearby businesses, and what it will have is it will have parameters like latitude, longitude, and the radius, and it will return a list of businesses. So basically this list of business one API will return, and there will be another API. What it will do is, suppose this is Manila Bowl, right? In case I am tapping onto the Manila Bowl, I need to see the details of it somewhere in this pane. So what my expectation would be, the moment I'm passing some kind of a business ID, like from this list of businesses, whatever the business ID I will get, it will return me the detail of the business, like what is the actual location, what are the detailed reviews, and all the other all the other further details. Now this is from this user perspective. Now just think in a different way, from where does all this data come, like this Manila Bowl, Wingslut, Matco, from where does this data will come? This data will be coming from uh, by the will be entered by the businesses itself. So suppose I am owning a certain business, what I will do is I need some provision to enter my data into the database. So for that, what I will do is I will, from my business end, I will definitely need some kind of a portal, and which also needs some kind of a endpoint which will create, update, or delete my businesses. So this will be like pretty simple. From the business perspective, what we are going to do is like we are going to have something like create business, we are going to have something like update business, and we are going to have something like delete business. Now what this create business will do is this will be like probably return something like a 200. Okay, the update will return something on 204. So we will we will probably not explore all those intricacies, but just understand on a very high level that the whole um, this particular bus- businesses of this list will be created and edited by somebody else at the business end. So this is on a very high level what will be my endpoint. Now let's talk about the database. So in any day zero architecture, if we are having some kind of a relation among data, so you will see that the RDBMS is always the best thing to follow. So why RDBMS? Now I'm going to write a statement which might, like, many software engineers sometimes doesn't agree with this, but I have seen this in my experience, that in any RDBMS system, if you drop your foreign keys, that in that case you can one can enforce this system to work as NoSQL. So we can actually get the best of both the worlds, but we will gradually see why RDBMS might not be the best here. So if we just try to explore what are the business parameters here, and what are the how we are going to query the data, probably we will get some further idea. So let's think about this. This is suppose this is the main business table that I'm going to have. So and here I'm going to have like a lot of data. So I will just take a snapshot of some data like this. Okay, so suppose there is this business ID, it is going to have some kind of a latitude, longitude, and all this data like address, city, state, this is not very relevant for me right now, so I'm just leaving it. And the business detail will be probably held by some other table, because this is a primary key. There will be some other business detail table will be there, which will hold the detail of any given business. Now coming to this discussion, like if I'm already having this kind of latitude and longitude, and if I have to make this particular endpoint work, like, then what would be my given query? So suppose I'm having this endpoint, and what I want to do is from my mobile, from my this user from his mobile, want to hit the database, and get the nearby businesses data. So how is he going to do that? So when he hits this database, what will happen is, in case I'm maintaining RDBMS again, what will happen is there is a certain query we have to write for this, and of course there will be a API layer in between. So I'm not denying that, but this API layer, this this get business nearby, this API layer, what it will do is it will fire up a query, and the query will somewhat look like this. Let's paste it and then explore it. Okay, so what we are going to have is the business ID, latitude, longitude from the business table. So this is my business table, and what I'm going to do is I'm going to have my latitude minus radius, and like, because plus minus I need to do for the latitude and the longitude both. And of course the radius calculation is not as simple as this. All the radius needs to be all the radius needs to be uh, converted into some scale to make it work within the latitude longitude. Okay, and trust me, this thing actually works if you have a very small data set. I have used it in one of the logistics companies database, and it worked okay, because we only had some 250 locations there to handle, so this thing worked. I'm kind of copy pasting all the ideas from there only, but we will gradually refine it to like a higher scale stuff. So if you see this, suppose my own, suppose this user's latitude longitude is something like 37 dot 77.7749, and longitude is something like minus 122.4194. So if we run this query, what will happen is, at first the latitude filter will at first this filter will fire up, right? This filter will fire up, and what it will do is it will give me a section of data. What this data will have is it will give me the business of 1, 2, 3 and 4. Again, like, if I actually spin up a database and insert this data, you will see that uh, in with respect to the latitude, these are the 4 businesses it will return. Okay, and then the second part, when I say second part, I mean this longitude calculation. Okay, so this longitude calculation will also give me one one section of data, and here the data will be 1, 2 and 3. So this longitude against this longitude of my current location, it will give me 1, 2, 3. Now what this query will do is, this query will do a intersection, and the output of this intersection will be, 1, 2 and 3. um, but this is not a very efficient approach. Why? I just want you to pause it for a few minutes and just think it through why this is not a very efficient approach. Then probably you can unpause and try to see my explanation, whatever I am putting through, and you can add, of course, your own version in the comments as well. So the final result, the final results that we got, it is basically, so what are the operation is happening? It is at first one filter, like two filter condition is happening, we will see, and after that one intersection is happening. Okay, so though we can put index on latitude, lat and long, both of this column, even if we put latitude and longitude index, still each filter can return a huge number of data. And because you can see, like, we are here only dealing with 5 data, so probably the scale we are unable to show through the design. But if we explore it with like maybe 1 million data, then we will see it will return a huge amount of data. And the problem that it will bring to the plate is, again, getting this two data and getting their intersection will cause like will cause a very slow query, and also a lot of load into the database, because the database has to do all the heavy lifting over here. So the query treats this latitude and longitude as separate dimension. That is why this problem is happening. Now, what will be the possible solution? Generally, whenever this kind of discussion happens, people directly go into some kind of like quad tree, Google S2, or geohashing. But trust me, there are like this databases like SQL Server, Postgres, Oracle. They have or even databases like PostGIS, they have lot of features which can handle geospatial data. So in case you are working on SQL Server, there is a certain thing called a geography data type. Okay, so in the SQL Server we have something called geography data type, and there with uh, a function called st distance, what we can do is we can do this kind of calculation. But again, this geography data type is for geospatial data. Okay, so when we are talking about the geospatial data, it is not only latitude longitude. We have to see geospatial data as data like um as data where we not only have latitude longitude, but plus uh, the height of that area, the environmental density. There are lot many parameter like comes here. So my only reason on why I am talking about this SQL Server geography data type, or in Oracle also we have a similar geospatial functions are there, uh, like SDO geometry. In Oracle we have something called SDO geometry. um, but again, this is not exactly for latitude longitude. It adds a lot of other overhead. So this is like maybe i i I have read somewhere that there are, for some environmental conversation or some resource management in some government website, they use this kind of SDO geometry, ST distance, this kind of things. But I myself haven't used it. But again, for this environmental data, this SQL Server, Postgres, Oracle, PostGIS, they are very good. But this will not serve our purpose here. If we are using this, this will be simply a overkill. And also like there can be some performance overhead as well, because like there will be a lot of other data on top of this. So what will be the correct solution? Before jumping into the correct solution, let's think how how our world is divided. Okay, so suppose I'm giving you a world map like this. Okay, suppose there is a certain world map is given like this. Now, as you can see, like there are four quadrants to that. So dividing it into this four quadrant. Okay, like in a 2 bit, like this is 0 1, this is 2 and 3, right? If I just think it in the actual number terms, what it is doing is it is going to divide this four the whole world into the four quadrant. And we can gradually keep on dividing these areas further. How? So let's take only this quadrant. Okay, let's take only this quadrant. And what it will do is it will basically Just give me 1 second. This quadrant, if I take, what it will do is it will further divide this quadrant in this manner. So this is called um, like the bifurcation of quadrant by quadrant of the whole world, and this can go on and on. Like suppose if I keep on dividing in this way, Google headquarters, suppose there is like when I was studying around it, so the Google headquarter has a this will be the quadrant bifurcation of the Google headquarters. So if I go into if I keep on going here, like suppose at first I go into 10, right? So then 1001, and in this way if I can keep on exploring this, I will find it somewhere. I will find the exact location of the Google headquarter. And not only that, this is not very efficient for storing. Now, if I keep on storing this data into my database, this will not be a very efficient approach. So what the computer scientist came up with is, we can take this data, because this data is getting huge. We can take this data and we can do a base 32 binary encoding on top of it. So by doing this binary encoding, what it becomes is it will be something like 9q 9HVU, something like that. I might be wrong, but like I noted down it somewhere that if we are doing a base 32 binary encoding, it will become something like this. Now, now the things will start looking interesting. When we are putting the base 32 binary encoding over there, we will see that our blocks will be something like this. So here you can see like Judah Street, anything around the Judah Street and the Kirkham Street, they are with the same prefix of 9q. This is the most interesting finding that we got. If we keep on dividing the our entire world like this way, and when we find the prefixes, so the nearby locations are always near about this prefixes. So suppose there is this Lawton Street, you can see, right? Like if I have to point this thing to you, the Lawton Street, and here something like Kidham Street. Suppose there is a certain point here in this Lawton Street, and you are standing somewhere here, okay, and you want to see whether what businesses are there nearby. So when we query this thing, what we will find is we will get to see that anything that around this prefix, so you see this prefix and this prefix, they are quite similar, right? So anything around this prefix, I can mark them as my nearby location. So the places which shared with shared prefixes, we can tell that they are the nearby one. Now the now the next exploration would be like how our current design would look like. If I just have to think through what we have done so far is, suppose there is a um, yeah. So when we are putting our businesses over here, suppose there is a database. Yeah, suppose there is a given database, and what we want to do is in our database, yeah, in our database, how we are going to do is, so there will be an intermediary function, which function what it will do is like any data that comes from, suppose the data is coming from some business, Okay, so what it will do is it will convert that particular data. Suppose all the lat long, it will convert into the base 32 prefix into a base 32 based mapping, and then it will store into the database. And when this fetching will happen, like when a certain user will try to fetch the data, what he will also do is he will also pass, like for example, suppose here we are having a user. Suppose there is a certain user is there, and what this user will do is he will also uh, pass his latitude and longitude as over here, and then it will again hit our database. Then it will hit our database, and it will return the data to the given user. Okay, so this is what will happen on a very high level. If I have to see, so there will be a transformer which will convert the latitude longitude into the base 32. Now, what kind of database we are going to use from here? So, on a very high level, you might be thinking that suppose I will just write a very basic query, something like this. Select, I will use my RDBMS, and what I will do is I will just do a select star from geohash index, where geohash is like this is this. Now, exactly for geohash, Redis has a very brilliant solution for this, which is being called as Redis geohash. Now, as like we will also see how this data actually being used, instead of instead of just blindly taking the turn. So let's think about this. So we have our Redis geohash over here, right? Now you see, this is what I have done. I already have my Redis up and running, right? So what I have done over here is I have connected it to my Redis, and I have added all these locations over here. So this can be multiple locations, and in Visual Studio and C Sharp I have done. So you can see like the syntaxes are like this. For Redis, of course, I had to add this particular library, and then there is a very good function Redis gives us. It gives us something like a georadius, what where we have to tell Redis is like you take this particular uh, you basically take this particular locations, or the Redis key as input. You scan through all the key with this given latitude and longitude. I can just show you the what this method stands for. You take the latitude and longitude, and then what you do is you, based on that radius, miles or kilometers or meters, you try to find out all the locations that are near to that. So suppose if I'm running this, okay, let me run this. Again, the reason I'm showing you this is what we have to think through whenever we are, yeah. So let me, okay. Now it will keep on iterating all the results, and what it will do is, following business ID, it will keep on giving me that which business ID is within a certain, with, within the certain range that I have given over here. So you can see like I have already printed that following business IDs are within 2 mile radius, and here I have passed this 2 mile, and that is why it is giving me all the data which are within 2 miles. So if I just run it through, you will see that it has given me all the data. Okay, all, like all the Redis, all all the business ID which are within 2 mile. And one of the interesting thing is you will see that this is not exactly ordered, uh, because Redis is more worried about how exactly we can uh, how exactly we can give the result faster instead of ordering the data. So this is a very good option. Instead of taking it into the SQL server, we can just use Redis, and you can see how easily it gives the data. And trust me, like when we are seeing the huge applications like Yelp or multiple the nearby sort of services which gives you the nearby business, uh, nearby restaurants, nearby hotels, those kind of those kind of information. They definitely have a they definitely use Redis in most of the cases because this is very very popular. Now, so for today, I'm not going to make this video any longer because if I cover the other aspects of it, which I will cover in a part two. It will be very, very long video. What we are going to do is we are going to keep the Redis geohash idea for the time being, and then we are also going to explore Google S2, how Google S2 can solve this problem for us, and what are the advantages of Google S2 over Redis geohash. So here, what are the things we have learned? We have learned that what are the API endpoint, what database should we use, like are we going to use SQL server or Oracle sort of a thing or any other thing. So we came to conclusion that Redis we are going to use because this is widely being used and Redis has a very good functionality for the geohashing. And as a next steps, what we are going to do is we are going to explore the other options like Google S2 and then Google S2, yeah. And then what we are going to do is we are going to finalize our system by considering all the scaling, by considering all the scale, availability, and the other factors, and then we are going to wrap it up. So this has been the part one, and in the part two, we are going to cover all these things. Thank you very much. Please do comment in case you have any question. I will try my level best to answer that. Thanks a lot once again. I wish you a great time ahead.